1866.
What we're going. So just kind of
Fourth
talking.
grade, is that what we said?
Right. Probably mention it, but you guys, I don't know who was president at the time. Hello, hello. You got it? I got you. You got me? Yeah, okay. All right. Very good then. All right.
Okay, could you count to 10 first, please? Test your microphone.
See, that's where some of our grant money goes to.
1, 2,
There you
3,
go, you're
4,
fine.
5.
Awesome, thank you.
Okay.
If he asked you to say anything else.
Do that
Okay,
because
you
a lot
ready
of
to
times I
test the
forget.
microphone? Count to
He's
10
going to
for
need
us.
you to count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now your turn.
1, 2, 3, 4, 5.
There we go, sounds good, thank you.
All right. So every time that we are on,
Oh, I have
at
to
the
plug it back
beginning of the
in.
show, you're going to look straight this way. Okay? After we go at the start of the show, we're always going to be looking at
Thanks.
this camera. So when I'm like this, you need to make sure that they can see you because you're at the start of the show today. All right. So don't
Yeah.
like hide behind me. Always be up close to the counter.
Thanks.
Got it? then when we're through, I'm going to send it out to some place that we're going to be filming. So you just opportunity to get out.
Sounds great.
All right. Oh, I can't go anywhere, so bring them in. That is difficult? No.
Not really.
Do some
At
of those
least
today.
not in math.
Have you done? Write down an example of maybe what you did? Your lunch period, I will have something else for you. But I'm never going to remind you. You have to remember.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us, we have one of our very special guests today, Makai. Makai, if somebody wanted to get a hold of us, how would they do that?
For math homework help, call in Bakersfield 636-4357, toll free 1-866-636-6284, email dothemath@kern.org or online at dothemathonline.net, and social media, Facebook, Instagram, Twitter, and YouTube.
You have all that stuff? Like all those phone numbers and emails and social media? I don't have all that either, just when I'm here. How's fourth grade going?
It's going pretty well.
Yeah? Why don't you let everybody know where you go to school?
I go to Stockdale Elementary,
How long have you been there?
3 years.
3 years? And everything's been going nice and smooth? Math is
much.
going all right?
Yes.
Yeah? All right. Well, you know what? We have a lot of stuff going on this afternoon. So why don't we just get you to work right away?
Okay.
Over to the board, young man. So one of the things, since you're in fourth grade, you're going to start working with the order of operations. Okay?
Okay.
So I'm going to give you a problem. Cindy's going to write it up on the board up on top, and then she's going to introduce you to the order of operations a little bit, and we'll work on that problem. All right? So here's the problem. We have 3 times 5 minus 8 divided by 4 plus 6.
So just before I start, have you ever seen a multiplication written like that?
Yes.
Okay, just making sure. Okay, so order of operations. So you know how you read left to right on a book? Front to back, you don't start at the back, you're not supposed to, right?
Yeah.
So in math, if you go left to right, sometimes you end up with the wrong answer. So when you have a math problem, there's an order based on the operations. So the first thing you always look for is parentheses, okay? So I'm gonna write P for parentheses, okay? And then the second thing you would check for is exponents. Do you know what those are? Probably not yet in fourth grade. It comes next, but you probably wouldn't have that till a little later. Okay, so exponents are 2 to the 4th power, for example. Have you ever seen a power? Like a little number up above, right here?
No.
Okay, you will eventually. So we'll kind of ignore that one for right now, just because in fourth grade you won't see that yet. Okay, so then multiply and divide. So I'm gonna write them like that, but they really go together. Multiply and divide, and you wanna go left to right whenever you're multiplying and dividing. They're equally important, so it's just whichever one you see first. Out of those two, you do it first, all right?
Okay.
And then you have add and subtract, and those also go together.
Yeah.
Okay, so they're left to right. So some people say PEMDAS. That's what they're talking about when they say PEMDAS. So parentheses, exponents, multiply and divide, add and subtract. Okay, so this goes together. So it could be DM or MD, and it could be AS or SA. This is just like a nice way to memorize it, so that's why they usually put it in that order. Okay, so if you were doing this problem, order of operations, what do you think you were gonna start with? Or how about you go ahead and start working it out and we'll see.
Okay.
Just, yeah, there you go.
So 3 times 5, this would equal 15. Then minus 8 would equal 7 divided by 4.
So what do you notice right there? What's happened? What can you do 7 divided by 4 whole evenly? All right, so let's go back to this. So there were no parentheses.
No.
So you're gonna work on these two, right?
Yes.
You gotta do all of these before you do any of these.
Okay.
Okay? So where do you feel like you could catch your mistake? So you did do 3 times 5, but then what'd you do?
I minused it by 8.
So that's not one of these, right? So we want to take this part, okay, and instead of subtracting right now, we want to finish any of these. So where else do you see a multiplication or a division?
Right here.
Okay, so you want to do those 2 numbers. So basically you just bring that down,
So bring
the subtraction symbol.
this down. Then 8 and divide it by 4. Then that would equal 2.
Okay, so just this part equals 2, right? Just to make sure.
Yes.
So we still have our 15.
Yes.
Okay, so we're going to just equals 2. All right.
Yes.
So it's 15 minus 2 now, the answer to that. Okay. What else is in the problem still that
Plus
you need to bring
6.
down? So go ahead and bring that down behind your,
Right here.
yeah, right there.
Okay.
Okay, so
6.
now is there any more multiplying or dividing?
Not
All
that
of
I see.
operations are just addition and subtraction now, right? So now
Yes.
you're going to go ahead and finish it with the adding and subtracting.
So here would be 13, and then plus 6 would equal 19.
There you go. So it worked out at the end. Just that one little mistake right there was like,
Yes.
wait, I can't do 7 divided by 4, right?
Yeah.
Yeah, so good job.
There you go, your introduction to order of operations, and please excuse my dear Aunt Sally. I'm sure you'll hear that in the next couple of years as well. Hey, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News. Once again, lucky enough to have somebody in studio with us today. Today we have Katie, and how are you?
I'm well. How are you?
Excellent. Why don't you let everybody know the organization that you're with and your role with that organization?
Sure. I'm with Junior League of Bakersfield. This year I am their current president, and I got started in Junior League about 5 years ago.
Okay, now I know that the president of Junior League has a very busy year.
Yes.
And so where are you in this year? Like, are you starting in the middle or towards the end? Where are you in this year right now?
Our year actually starts June 1st, so
Okay.
I'm about a quarter of the way through.
That you seem pretty pleasant right now for everything that you guys have going on. So for people that aren't clear or maybe have never heard of Junior League of Bakersfield, what is that organization?
Junior League is part of an association of junior leagues all across the country, where there are over 290 organizations. Ours started about 50 years ago, and we're an organization of women committed to promoting volunteerism and developing the potential of women, and really giving back to our community.
Okay, so that's the big part, giving back to the community, because I know that you guys have supported Do the Math in the past,
Yes.
and there are organizations that provide services for students that you help them with,
Yes.
right? So what are some of those organizations and some of the examples of ways that the Junior League has helped other organizations provide services for students?
Sure. So, for example, we do like not just for schools. You want
Right,
so
any kids at all?
sure. We help kids with the Alliance Against Family Violence. We help children at the Bakersfield Homeless Center as well, and Jameson Center. Those are a couple of our bigger projects that we
Okay.
have. We do a lot of hands-on opportunities just throughout the community that also support other nonprofit organizations.
And I know we've got some photographs here,
Yeah.
and maybe you can kind of explain as we go through these.
So this is one of our Champ Camp birthday parties at the Bakersfield Homeless Center. We do this once a month, and that right there is Jeremy Statt. He is a NFL football player, and he donated his time to come in and spend time with the children, hang out with them, play with them, sign some autographs, and it was just a wonderful experience that we were able to provide.
All right, so that's Champ Camp.
Yes.
All right, so birthday parties and stuff like that. Now, I understand there's a lot of executive things you guys need to do, legislative and stuff like that. So
Correct.
tell us a little bit about that.
So that is our State Public Affairs Committee, and what they do is they go to the Capitol. They are working with our legislators here locally, and they're always monitoring where our bills are going within the Senate and the House and trying to see what legislation is being passed or could be passed to help our local community, especially women and children in our community, and how they can support those bills to then bring back to our league, inform us about them, educate us about them, and then we can actually support them in Congress.
So there's a lot going on behind the scenes that people are not even aware of, that you ladies have to do all of the time.
Yes.
That's why I was saying it's a lot of work.
It is.
That people may not realize. And you have other projects and things going on all the time. So what are some other things you guys have going on right now?
Currently, we are doing the birthday parties every month. Other projects we have, we just do what we call impact opportunities. So we have an entire committee that sets up things that we go and do throughout the community. So one of our standing projects is going to the Jameson Center and reading books to children that may be placed there.
Okay.
So we have that. Sorry, I'm kind of blanking right now.
That's
Some of
okay.
that.
There's a lot of stuff going on.
Yeah, a lot. This is actually a picture of one of the projects that we've done in the past. This is in collaboration with the Ronald McDonald House about 3 or 4 years ago. We raised money to buy those teddy bears, which is Along Comes Hope. And those teddy bears have a little recorded message in them that family members and loved ones could send to their children that are having to stay at the hospital for medical reasons. So we were able to raise those funds and then donate those bears directly to the kids in the hospital.
And a great comfort, I'm sure that is,
Yeah.
a child in the hospital being able to hear their parent's voice whenever they want to.
Yeah.
Makai, do you have any questions for Katie?
What big project have you worked on?
You know, one of the biggest projects we've done recently is about 4 years ago, we donated a $50,000 grant to the Lori Brock Children's Museum. Have you been there before?
No.
You haven't? You'll have to go check it out. So we were able to donate a huge grant to them, and they were able to update their entire, the Lori Brock Children's Museum. And now they have this wonderful playroom, this great play space, and even some STEM opportunities in there too. So you'll have to check it out.
Yeah, so we can see some of the photographs that are up there right now of the Lori Brock Discovery Center. And that is courtesy partly of
Partly of.
Junior League of Bakersfield.
Yes, sir.
So what are some things coming up? Because these are things that you constantly are working on, how you do them, and things that have worked in the past and how you've supported the community.
Yep.
What kinds of things are coming up for the Junior League?
So we do fundraising. So that's how we get our money to be able to do grants such as supporting Do the Math and other organizations like Lori Brock. We are going to be doing a Funky Sock fundraiser, so you'll be seeing us out at some of the community runs. And when we're there, we're actually supporting the nonprofits that are putting those runs on, because we do have vendor fees and things like that. So
Okay.
we're out there supporting them. We're going to be having a holiday bazaar coming up in December, where we're going to get some community members around, and you can do your holiday shopping at,
And where will that
the
be?
Junior League House.
Oh, so it's at the Junior
It will
League.
be at the Junior League House, correct?
So let everybody know where it is, because some people may not know. It's
Yeah.
downtown, but where?
1928 19th Street is the Junior League of Bakersfield Community Center.
All right. Well, you know what? I know that you're a busy lady, and being president, you're very busy, especially since you're only about a quarter way through this thing right now. So we do appreciate you taking out some time to come visit us and let us learn a little bit more about what Junior League of Bakersfield does.
Thank you for having me.
All right. Hey, we do have phone tutors available until 5:30 this afternoon. That is today's Math in the News. Time now to head out and about with our friends from Buena Vista Museum.
Hey, welcome to Science in the Real World, another episode where we get a chance to show you a little bit how math incorporates into science, incorporates in the real world. We're here live today at the Buena Vista Museum of Natural History and Science, a place that I drive by often and don't even know what goes on here. So I'm really curious to see what's going on. So we brought along Dave Hanley. He is the board vice president and secretary, and we're so glad to have you, Mr. Hanley.
It's my pleasure. It's my pleasure.
Really
Thank you.
glad you could be here. So when I drive by this place on Chester Avenue, right, I see the signs, it says museum, but I've never been in here. So why is this museum here, and give us just a real brief overview of what goes on here.
We originally started out, we were attached to COM.
Oh, okay.
Okay, and it was based originally on the Miocene fossil bed. Kern County has the largest Miocene fossil bed in the world. 126 square miles of fossil bed up in the foothills, both sides of the Kern River. That's why your kids ended up finding shark's teeth.
That's right. We were talking about that.
So,
yeah.
so I got involved with this partly because Dad was working with the reptiles out there, but I saw the natural history, and I love natural history. So we started with the natural history, but as I've come on the board in the last 20 years, we've had a huge interest in all of the sciences. Kern County has more science than any other county in the continental United States.
It's an amazing place to live, isn't it?
Absolutely. We're
Right.
blessed to really be here. We have the largest Miocene fossil bed. We've got the largest agricultural development. We've got more endangered species than any other county in the continental United States. We've got a spaceport out in Mojave. We have the Naval Weapons Center out there on the east side.
Yeah.
We have Edwards Air Force Base, where part of the time they developed the shuttle and the astronauts and the moon landers and stuff like that out there. We have all the way over, we have petrology, and the petrology's here because we had the Miocene fossil bed. That's where the oil got made.
Yeah.
And so we have the seismology along with the faults, where we have the Pacific plate dipping into the North American plate, and that subduction is what caused the tilt blocking, which provided us with the cracks in the earth, which made for the gold and the silver to become placer and became the foundation for Kern County, back with Havilah being the county capital. So,
And it gives Ridgecrest something a little bit shaken up over there too, right?
well, absolutely.
deal as well.
That's how the volcanoes got out there. So we've got the
Yeah.
obsidian, and so we just have more science. So we decided we had to be a museum of all the science. We want to attract all the science. We have more science than any other county in the continental United States, and we want to pay attention to that and educate the entire public of Kern County. The higher the per capita education in science, the higher the per capita quality of life, and that's our goal.
That makes sense too. I mean, there's so many things around us, right, that are our natural world. I'll ask some of my students sometimes about what's your favorite subject or what's your least favorite subject, and science ends up on both of those lists, which is a strange thing. But I think the students that don't like science don't realize how much is around them and don't realize how interesting it can be because they just haven't been exposed to it. They haven't been taught about it. So this place seems to at least get them started on a path to learn about what's around them, right?
The number one question we get down here is real. Okay, I didn't get my master's degree until 2011.
Yeah.
Okay, my thesis
Yeah.
was real versus contrived.
Oh.
Real attracts 20% more and more precise observations than contrived.
Right.
So, number one question we get down here, is that real? Is that real? Is that real?
Right.
Real matters. I've got my YouTube channel. I've got my nail bed on the YouTube channel with a 285-pound kid dancing on my chest on the YouTube channel. Do you think, if I've got that nail bed here and I've got the board, do you think it's worth more to the person here for me to have them stand on my chest or watch my YouTube channel?
Right, right.
You know, it
They
makes
want
a
to have it
difference.
right in front of them.
Real matters, and that's the power of a museum. And we've got the real, and we do a sampling of the real here at the Buena Vista Museum so that everybody gets to have it.
Yeah.
And so.
And then, so do schools get to visit here? I mean, do you take students
absolutely.
in?
Oh, absolutely. We get
Okay.
students here. I used to do field trips with students. You know about
Yeah,
that.
yeah.
I used to take field trips with students. I'd take them to the LA Natural History Museum before we had this.
Right.
Well, what I started doing later on was I'd do the Natural History Museum, and we'd come by here and we'd do the museum here at night.
Yeah.
And so we'd be able to do even a better extension. And some of them liked here better than LA.
Oh, yeah. Well, it's a shorter trip, and you can think about what's going on, and it just seems, again, so real because it's
We
so
don't have
close to where we
Tommies
are.
yet. So we don't have Tommies yet. So.
Well, there's always room to improve. You know, there's always ways that we can make it a little bit better. We're so excited to see all kinds of things that we have going on here. And of course, it's the animal heads that catch your eye when you first come in, but I know there's a lot more to this place as well. So when we come back, we want to learn a little bit more about what actually happens at the museum, what you can see here, what kinds of sciences are discussed, and maybe even a surprise or two about what really exists around us here in Bakersfield and in Kern County that we might not even know about. And I know that Mr. Hanley will be able to show us that.
Do we have them to talk about do the math, why it's with do the math?
We can. Right when we come back, we're going to hit to
Okay.
that, no problem.
Okay.
So we'll be back just a moment. Back to the studio.
Hey, you know what? We'll be happy to go back to you guys. A lot of fun down at Buena Vista Museum, a lot of things going on. And as he was talking about, a lot of science here in Kern County, more than any place else in the continental United States. We do have phone tutors available until 5:30, but more importantly, we have Makai in studio who's learning about the order of operations. So, young man, back over to the board and we'll do another problem. All right? This one, so we'll have Cindy go ahead and write it up on the board for you, 5. And then we're going to open up parentheses, 2 plus 4, close parentheses, plus 15, divided by, open parentheses, 9 minus 6. Close parentheses. So now, Makai, you've got parentheses to deal with. All right?
All right, so do you still remember what we talked about? Do you read?
PEMDAS.
Yes. So what's the P stand for?
Parentheses.
All right. So do you have parentheses?
Yes.
Yes, he just told us we did, right? Okay, so you want to start with whatever work you see inside the parentheses.
Okay, so I have 2 plus 4 and 9 minus 6.
Okay, so you're going to do each one of those.
So this one is 6, and this would be 3.
Okay. And so then we're going to bring down everything else we didn't change yet. Do you know what the 5 against the parenthesis means?
5 times?
So if I put a dot, you're okay with that?
Yes.
Okay. You'll start seeing it more like that. Okay, and then bring down your 15 and your divided by symbol.
15 divided by...
All right, so you got your parentheses finished, and there's no exponents. So multiply and divide is your next step. So
Yeah.
what parts are you going to do?
So this first.
Okay.
So this would equal 30 plus 15 equals 45.
Okay, so before you keep going, ready? So you got your parentheses, no exponents, multiply and divide. Did you do all of your multiplies and divides before you did an adding?
Yes.
Did you? Did you add already?
Yes.
So, can you find your mistake? All right. So you can just go like, what are you going to erase? Okay, so you have your 30, right?
Yes.
But you don't want to actually do this yet because you
I
also
haven't
have a
divided.
division, right? Yeah. So let's just erase this right now. Okay, so you got your 30. Now what should you do instead of adding?
I divide
Okay, what do you divide?
15 divided by 3.
Exactly.
Do you want me to do it up here? or down
So
here?
just like you did here, just write, and then what it equals. Okay, and then so what would go between these two these two numbers? What's still in your problem right here that you haven't done?
the plus.
Okay, so now all you have to do is finish it by addition, right? So you got to watch out for those when you have two separate things. Don't accidentally add first,
Should
right?
probably make this a little more visible.
It's all right. Okay, so 35 is your answer. There you go.
I think he wants to.
You're trying to
move
line
a
it all
little
up
bit
so it looks
it's a little
better?
neater, so that's fine. All right, so 35 is the correct answer, okay? So you have a little bit of a better idea on order of operations?
Yes.
So you have to remember to do all multiplying and dividing before you do any addition and subtraction.
Yes.
All right? Well, let's see, Hotshot, erase the board. I'm going to find another one for you right now. This one is coming right out of the book, specifically designed for you, Makai. All right? So, open parentheses, 7 plus 3 times 2 plus 8, close parentheses, divided by 7.
Okay.
Okay, so what are you thinking?
I'm thinking 3 times 2.
Okay, because they're in parentheses and it's multiplication before
Yes.
addition. Nice, okay, good. All right. So whatever you haven't changed, you should just always bring down so that you still
Yes.
have all the rest. So this is like the only thing you changed, right? So everything else comes down.
7 plus and then E plus 8. Then D divided by 7.
Okay, so did you do all the work in the parentheses already?
So remember to
No.
rewrite the
Okay,
parentheses.
so go ahead and put your parentheses on there still then, since you're not finished with them yet. That way you don't accidentally drop them. Okay, so we still have our parentheses, right? We did.
Yes.
You did 3 times 2, you got 6. Now what should you do? You still want to get your parentheses answered. So inside the parentheses, even though you see that division,
Yes.
It's outside of the parentheses, so you still have to finish parentheses first.
Okay. So this would equal 13, then plus 8. Okay, so plus 8 equals 21.
Okay, so your parenthesis part became 21, so
Yeah.
what's still left?
Divided by 7.
Okay. So you got 3. Nice.
There you go. Nicely done. So you're getting a little bit more of the hang of parentheses in the order of operations. All right, so nicely done. 636-4357 is the phone number for just doing that little bit with order of operations and getting a little bit better at it. We're going to award you with a couple of tickets to any CSCB athletics event of your choice. You have a favorite sport you like to watch or participate in?
Soccer.
Soccer? Well, you know what? Men's and women's soccer is going on right now. Coming close to the end of the season, but you've got 2 tickets. You can go out and check out a game. How's that sound?
Sounds great.
There you go. Nicely done. We'll be back with more right after this. Today we're at Rio Bravo School, home of the Gauchos, and we're here to... Once again, we're with the 5th grade students at Rio Bravo School, and we're going to be working on some more math, obviously, but this time with order of operations, okay? And raise your hand if you've ever heard of, please excuse my dear Aunt Sally. Do any of you actually have an Aunt Sally? You do? Excellent. I think you're maybe the second person I've ever met that really has
Actually don't.
an Aunt Sally.
I don't have one.
You wish you had one, right? Okay, so here's the paper that we're going to work on. And you guys can work on this individually, or we're going to work on it together. All right, so let's take a look at the directions. Well, actually, can you do me a favor, read the directions?
Complete this grid with the digits 1, 2, 6, each used only once to make the sum correct. At no point is a decimal or a fraction used.
So these are going to be the whole numbers, 1, 2, 3, 4, 5, 6. And it says to make the sum correct. What is the sum we're looking for?
35.
How do we know?
Because it says it on the opposite side of the equation.
Right, on the opposite side of the equation, after the equal sign, it says 35, okay? So we see there are 6 blanks in here. Okay, now we have to do these order the way they have them. Okay, so it has multiplication and division at the beginning, which is good, because that's the order of operations. So you need to put the numbers 1, 2, 3, 4, 5, 6. You can't use any number more than once, okay? You put the numbers in here, and then go through it and see if it comes out to be 35 at the end, okay? Here's an example. Let's just do it right in order, okay? So above the box, okay, don't write these in the box right now, write it above the box. So we'll put 1, 2, 3, and go like that. So we'll just go 1, 2, 3, 4, 5, 6 in that order, and we'll just see if that works or what it comes out to be. All right, so let's do the operations now. What is 1 times 2?
2.
What is 2 times 3?
6.
6 divided by 4.
1.
That's a problem now, isn't it?
Remainder of 2.
Okay, now, so we're going to have a decimal number in there, right?
And it says no decimal.
Right. So let's say it's 1.5, okay, plus 5. So what's 1.5 plus 5?
6.5.
6.5. 6.5 minus 6.
0.5.
0.5. Is 0.5 35?
No.
Long way away, isn't it? So you see how this is going to work? So I had you put those up on the top because I didn't want you to put what you come up with in the boxes. You have erasers, so you're going to be able to, because is the first time going to work?
No.
Probably not, okay? So write lightly in case you have to erase, and go ahead and work on this and see if you can come up with the way that will come out to be 35. more clue?
Yes.
Here's my clue for you. Keep trying.
That's really helpful.
Well, I gave you one clue. I told you where one was. You want me to tell you where they all are?
Yeah.
That's not going to happen. At the end, I will. Remember, you can only use each number once. Something happened. What have you got there, sister? Let's see. What number are you missing?
I almost got it, but I was going to put a 6 right here, but I can't.
Well, put a 6 there. Get rid of your other 6. What's half of 6?
Oh.
There you go. Okay, now you have 2 2s, though.
Oh.
So change that one. What do you want to make that?
4?
4. So put a 4 in there. All right, let's read this and see what you've got.
5 times 4 equals 20. 20 times 3 is 60. Divided by 2 is 30. Plus 6 is 36. And then minus 1 is 35.
There you go. Nicely done. Order of operations with the 5th grade students at Rio Bravo School.
Oh, we're gonna have to wear the same shirt.
I had these tailored. You know what that means? Perfect fit. Perfect fit. Perfect fit, or would you like a larger one?
Good enough.
That's okay. Perfect fit, or would you like a larger one?
Perfect fit.
Perfect fit. That's what. And we certainly did have a lot of fun with the students at Rio Bravo School. And we have Makai in studio with us right now, a 4th grade student from Stockdale Elementary. We were working with order of operations from the students on the video right there. You've been working with order of operations today, learning a little bit about that. And we'll put Makai back to work. But first, we're going to go back out to Buena Vista Museum and visit with Scott.
Hey, we're back with a little math in the real world, and we've already been talking to Mr. Hanley about the amazing things that happen at the Buena Vista Museum of Natural History and Science here in Bakersfield. And some people might be wondering, why are we doing science and do the math? But really, that goes back to how you explain science to young people, right? It's the best way to do it, and that's why we have math.
One of my other things, I'm eclectic. I do a lot of stuff.
Okay.
One of the things I do is I'm one of the adjunct teachers at the University of Laverne for elementary school science methods.
Right.
And in order for them to pass the C-set, they have to know certain things. And there's something on the C-set, it kind of frustrates me, but I have to tell my students so that they can pass the C-set so they can become teachers.
Yeah.
And one of them is that in Greek, science means to know.
Okay.
But that's not what scientists do. That's the one that kicks me, is that scientists look into the universe, no matter what your denomination, and they look for patterns in the universe. And
Right.
what better way to describe patterns than with mathematics? And so the
Right.
language, that's why I think that a lot of mathematics ought to be taught through the sciences, because that shows you the application for the different formulas that you do.
There's the real world part. Show me,
Show me,
right?
show me,
Let's
show me.
look at a couple patterns here, if you don't mind. We were talking about these earlier.
Okay,
And
well,
so,
well, yeah.
would you mind if we look at these?
Not
We were
at
just
all,
talking
not at all.
about patterns, so I thought this was neat.
People learn to read by different methodologies, and so but every person's got a different set of, whether it's partial word recognition or whether it's whole word recognition, whether it's phonics, that sort of thing. But with mathematics, you can learn your multiplication tables many different ways.
Right.
And so you might learn them by rote memorization, but only a portion of the population is effective with rote memorization.
Okay.
When Dad had a stroke and he lost his multiplication tables, I was able to teach him with geometry. He didn't lose his geometry. He could do the triangles for 3, 6, 9, and so forth.
Okay.
Squares. But now there's a Marcy Cook thing where she does stuff with the hundreds table.
Okay,
And
so this
so-
is a table of the numbers 1 to 100.
Right.
And these are the multiples of 11. So this
So
is
that's your
11 here.
bishop.
11,
That's your
22,
bishop going
33,
that
44,
direction.
55. So in terms of chess, this is a wonderful representation of the way that the pieces move, right? So yeah, we have a
Correct.
bishop here, and over here we have 7s and 8s. What's here?
Well,
This-
okay. See, 9s would be
and we can do the
the
other one.
bishop on the other side.
Right, you can go this direction. Yeah, the multiples of 9. That's a good point.
And so some kids can see the table
Yeah.
better than doing the rote memorization. 8s
Sure.
are the knight, Down 1 over 2, down 1 over 2, down 1 over 2.
Yeah.
And so you get this weird pattern with the 7s, where you start out here 7, 14, 21, and so these are nice diagonals that do serious skips. There's not a piece on the chessboard that matches exactly what 7s do.
But what a wonderful conversation to have with a young person when you say, this matches up with that, this matches up with this piece. What do you think the 7s do? And they might make another association that doesn't have anything to do with chess, but then they've made their own association.
And they
own it.
And
they
they
own
do
it.
it. Then they do
that's
it. Well, yeah, the fours table is really fascinating. You know, I look at it and I think about it like a keyboard.
Yeah?
You got a 4-note spread, but you got 2 together, now you got 3 notes together, now you got 2 notes together, you got 3 notes together, you got 2 notes together, you got 3 notes together, you got 2 notes together, you got 3 notes, and it might be that's the thing, you know, columns for the 5s and the 10s.
Right.
You know.
So we have some materials here, and I know that there's some really neat things you'd like to show us. Maybe a little bit about sound, is that right?
Oh
that we're looking
gosh,
at?
okay, waves.
How about a lot about sound?
Okay, next generation science standards
Okay.
is about unifying concepts, things that apply all the way across the board. And so one of them that I had back in '97, we did technology integrating engineering with kids, and they made rap music videos. And there's a formula for rap. You take the central concept, you repeat it over and over again, and that gives you your cadence, and that gives you your note variation. And so these kids did their own research.
There was a science to the rap song.
Oh yes, absolutely.
Wow.
There's a pattern.
There's a
to the
pattern,
rap,
a little
to
bit
the
of
rap.
music. I mean, a little bit of math.
Okay,
in
and
it,
so here was what they discovered. They discovered that the central concept in sound is frequency for pitch, amplitude for volume, frequency for pitch, amplitude for volume. So, you know, so waves, you know, and so the wave goes on and on. It's just like that endless song, and the wave goes on and on.
Crazy.
And so we have waves in sound, we have waves in light, we have waves in electricity, we have waves in water, we have waves in earthquakes, seismology. We have waves in just about everything. The anatomy of a wave is basically, so the frequency, the length of the wave is the frequency.
Yeah.
And so the internodal distance, the distance between the cross center line, that's the frequency. But the height and depth of the wave at the antinodes, that's the volume. That's how loud the sound is.
Okay.
And so
sense.
frequency for pitch, amplitude for volume. Yeah, I wanted to make a trumpet. I had music as a thing. We were back in there, and of course we started out, we were looking at the elephant, and so I wanted to make a trumpet out of a clear tubing in a funnel.
Yeah.
I got a Bach 7C mouthpiece, and I put it on there, and I wanted to be able to do jazz, you know. But there's too many notes in there. That's frustrating. There's too many notes in there. So I went to the band teacher, and he said, you're talking about confined waves in a tube.
Yeah.
And so what you need to do is go to the lowest number, and the first break in the tube is 1 octave. The next break will be 5 notes spread. The next one 3 plus. Then the next one less than 3, and so forth, so that you get closer and closer together.
Wow.
And so I ended up being able to get the middle-sized one. I only had 3 notes on the small one, so the middle-sized one.
Wow.
So you can do
That's
jazz.
unbelievable. Even without a full-on trumpet, that's unreal. I'm really anxious to hear this one. We want to make sure we leave everyone hanging just a little bit so they'll make sure they return for the last segment. But gosh, what a great way to incorporate science and learning and math all together and make it real for a young person.
And the arts.
Yeah, and the arts too, that's right. And maybe even not so young people like this stuff too. Really appreciate your time. We're going to come back with a little more segment. Right now, we'll go back to the studio.
All right, thanks for that, Scott. And you never know what's going to happen down at the BV Museum. And wonderful way to incorporate math and science, and you can see a little music right there. You play any musical instruments?
No.
Neither do I. But you know what you can do? Math homework. Let's get going again. Here we go. All right, over to the board. So, order of operations, we're going to let you go on that for right now. Okay, so we're going to work with the distributive property. So what you're going to do is simplify this problem. So we have 7, open parentheses, 2k, close parentheses, plus 2. So close parentheses, plus 2, open parentheses, k minus 3. And simply evaluate that. Just simplify it.
Simplify. Have you ever simplified expressions where there's letters involved, variables involved? All right. So we get to kind of teach you a little bit here. Okay, so when it's still kind of like order of operations. You do have parentheses, right?
Yes.
So your parentheses, does this one have a math problem? What do you think 2K means?
2,000.
Ooh, nice. This is just the letter K though. So I like that though, because you are thinking. Okay, so this just means 2 times something, but we don't know what that something is.
Okay.
So since we don't know what K is, what value, it could be anything, they didn't tell us, we're gonna leave that alone. What about here? Can you do something that you don't know and subtract 3 from it?
No.
So you can't, right? Because
You don't know what it is.
All right. So this is where the distributor property comes in. Okay, so the word distribute means, do you know what it means?
Like, kind of give.
Yeah, exactly. So this is an example of distributor property. So this means 2 times this value.
Yeah.
All right? But we don't know what this value is because we don't know what K is. So we're going to give the 2 to everything inside the parentheses. Since it's a multiplication right here, we're going to multiply it to each thing. Okay, so 2 times K. Well, do we know what K is?
No.
But we also saw this 2 times K over here. So we can write 2K to represent it. So go ahead and write that.
Or do you want me to write it?
Just right here.
2.
Okay.
K.
So that's what happens when we give the 2 to the K. All right. So now we have to also do the 2 times the 3.
Yes.
All right.
So 2 times 3.
So go ahead and write what it equals when you times it, when you multiply it. Okay, so I'm going to rewrite this just so it's, so 2K, minus sign comes down, 6. 2 times 3 is 6. So this over here, we got the parentheses that needed some work to them because we needed to get rid of that, that set of parentheses. What do you think you do right here? Is 7, what's that?
Times.
Yeah. But you don't know what K is, but can you do 7 times 2?
Yes.
So go ahead and do that part.
7 times 2
So what is that?
equals 14.
Okay, and then since this has a K, you just keep the K on it,
Yes.
because whatever the K was, it's still going to multiply by the 14. And then the rest of this stuff, whoops, the rest of that is still there. All right, so you have 14 Ks, and you have 2 Ks, and you have minus 6. All right, so when you're simplifying with variables, anything that has the same exact variable can be added and subtracted together. It's almost like it represents, okay, I have 14 Kit Kat bars, and I have 2 more Kit Kat bars, right? So how many Kit Kat bars is that all together?
16.
Okay, so write 16K.
16.
All right.
Okay.
And then bring down the minus 6.
Minus 6.
This is just the number 6, right?
Yes.
So if these were Kit Kat bars and we had 16 of them, and then we have subtract the number 6, do you think you can actually, would that make sense? 16 Kit Kat bars minus 6 numbers.
No.
No. So these aren't, this is where you stop, because if this has a K and this doesn't, they're not considered like terms. They don't have the same letter, so that's as much as you can do. So that's why it's called simplifying. You're not really solving. So that's your answer right there.
And that's what you're going to start with, because if there's no equal sign in the problem, there will never be an equal sign anywhere else.
Right.
All right?
So
it's
So
just
that way you don't even need that right there.
is your answer.
There you go. All right. So that is the most difficult one. So now we're going to go back a little, and we're going to have you kind of work on these a little bit, all right? So clear the board. I've got another one for you. 9y minus 3y plus 12y. So simplify that one.
So 9. Well, you could do 9 minus 3.
Because they are both having a Y on
Yes.
them, right?
Then plus 12. Y. Well, do you want me to write the
Yeah,
Y?
write the Y.
Okay. 12. Y.
That's all right. We know what you mean.
12y equals.
Now hold on a second. Is there an equal sign in the problem?
No.
Then get rid of the equal sign. With these, just keep going down
Yeah,
every
like
time
you
you
did
go a
there.
step. Okay?
So you can still go ahead and, he's just saying don't put equals because you don't know
Yes.
exactly what the Y is. Okay, what's missing on your 18 though? of like labeling an answer in a way, right?
Yeah.
If it was inches or, I don't know, why. I came up with Kit Kat bars. I'm not sure about whys.
So when you got
Yachts.
down to the
18
end,
yachts.
you got 18Y, and that's as far as you can
Yeah.
go, right? So how'd that one feel? Pretty good?
Yeah.
A little bit easier, wasn't it?
Yeah.
Because you're starting to do them now.
Yeah.
Clear the board, young man. Let's try another one. All right. 3, open parentheses, A plus 2A, close parentheses. Simplify that.
Okay, so still think of order of operations because you do have parentheses.
Okay, so you
So let's see if, okay, go ahead. Yeah, you can do that, I guess. All right, so distributing, that's what you're doing. So
okay
3 times A,
3. Well, we don't know what 3 times. We don't know what.
so if it's just an A,
Yeah.
that's just one A. Like if it doesn't have the one, it's like saying there's an apple. There's 2 apples. So when you do 3 times A, it's like there's an invisible 1 right here.
So 3 dot A,
Okay.
and then we do 3 dot 2.
Okay.
Okay.
So that's for this part?
Yes.
Okay. So put the A.
2
on.
A. So this would be 6. So this is the invisible 1, right?
Mm-hmm.
So wouldn't that be 1?
So it's like there's a 1 right here. So you do 3 times 1.
Oh, okay. So that would be 3.
Okay, so I'm gonna just kind of, okay. I'm just gonna write it over here
Yeah.
just because it's running out of room. Okay, so that times, 3 times 1A would be 3A, because 3
Yes.
times 1 is 3 still.
Yeah.
All right.
3A.
And then you said 3 times 2,
6A.
okay. And there was a plus sign right there in between them, so we're gonna write it right there. Okay. So we have 3 times A is 3A, 3 times 2A is 6A, and then right here, can you do anything else to it?
You can't draw the equal sign, but 9.
Yeah, they're both like
Yeah.
terms, so they can go ahead and combine. So use the distributor property. I just want to point out that you could also have just thought of order of operations. Same reasoning, there's like an invisible 1.
Yes.
And you could add these together because they are both A's. So you could have done 3 stays the same times, because that's what that means, right? And then 1A plus 2A is 3A. And then multiplied it from there, and you would also got 9A. So there's like 2 ways to get it.
All right, there you go. Nicely done. So erase the board. And I was inquiring as to whether or not you've done anything with fractions. And you said you did a little bit last year. All right, so this is the problem that you gave me, first of all. 3 over 5, and then 2 over 4. And what were you doing with those, Makai?
I was comparing the
So
fractions.
explain how to compare the fractions.
So when I was comparing fractions, I was taught to multiply across diagonally. So you would multiply these to get 10, and then you multiply these to get 12.
And
And then you compare them, so this would be the bigger fraction.
Right. So 3/5 is greater than 2/4.
Yes.
Okay. Do you know any other way to compare fractions other than doing that multiplying that you just did?
Not that I can remember.
Ah, big day for you now, my young friend. Cindy is going to show you how you compare those two fractions, doing it a different way.
All right, so the reason this works is important. So, like, you're taught that, but it's like, well, I don't know why that's true, right? All right, so if you had something out of 5, 3/5 of a pizza, let's say, and
Yes.
2/4 of a pizza, do you think the sizes of the slices are always the same?
No.
Okay, because this one had 5 to begin with, and that
Yes.
one had 4 to begin with, right? So you need to make the bottoms a common denominator.
Yes.
Have you ever heard of that? Common denominator? Have you heard denominator?
Yes.
Okay, so the 5 and the 4 are the denominators of
Denominators.
the problem.
And
So-
these are the numerators.
And those are, good, nice. Okay, so you want to make these become the same number, all right?
Okay.
So what can 5 and 4 both multiply to? Or what can they both go into, I guess?
20.
Okay, So if you want to make the 5 become a 20, right, and you want to make the 4 become a 20, do you think the top is going to stay the same? Would it be 3 20ths and 2 20ths? If you originally had 3 out of 5 slices, do you think you still have 3 out of 20 slices?
No.
Those would get cut up, right?
Yes.
Okay, so what do you multiply the 5 by to make it become a 20?
4. So
Okay.
you multiply this by this.
So that, yeah.
6. This
Wait,
one.
wait, wait, hold on. So you had to multiply. Oh, I see what you were thinking. Okay, you were thinking since those multiplied, those must multiply. That's a
Yeah.
different problem. That's not for comparing. You just want to make whatever you change the 5 by, you have to do it to the top also. So if you did 5 times 4, you have to do 3 times 4.
So this would be 12, right?
Uh-huh. And then what did this one multiply to become a 20?
5.
So you have to multiply the top by 5. Okay. Now there's your 12 and 10, right?
Yes.
But now you see why. You can see why, because it's 12 out of 20 compared to 10 out of 20. 12 out of 20 is larger
Yes.
than 10 out of 20. So you were taught the multiplication.
Yes.
The reason why that works is because you end up multiplying these to get the
Yes.
common denominator. Does that make sense?
Yes.
Yeah?
Where did you get the 4 from?
That was the problem that you gave us. The 2 over 4?
You asked me where I got this 4 from?
Yes.
Okay,
Oh, okay.
so you asked me, or you said 5 and 4 can make 20, right?
Yes.
So the question, where the 4 came from is, how does 5 become a 20? What do you multiply
By
5 by?
multiplying by 4.
Right, that's why that's there. So
okay.
technically, we should write this here, because that's what made that become a 20,
Yes.
and that's why you get 10 there. Okay, good question. I like
All right,
it.
so I've got one more problem for you. So you can erase the board so you've got some room. We'll stay with the same problem. 3/5 and then 2/4.
Okay.
Now, instead of comparing these, I want you to put a subtraction symbol between them. So now, Makai, what you need to do is turn them into common denominators again, because you just can't go 3 minus 2 is 1 and 5 minus 4 is 1. So this will be the next step.
4, and then 5.
Okay.
Everything's good so far.
Yeah, looking good. So now instead of
There you go.
comparing
So now
them, we're going
12
to put the
minus
math
10
operation
is
down there.
2. So you've got 2 20ths. And we'll let Makai finish that up because we have one more opportunity to head out
when
to
you're
the Buena
subtracting-
Vista Museum.
You don't change the bottom at all?
Hey, a little math in the real world. We are back at the Buena Vista Museum of Natural Sciences. And boy, we are learning all kinds of stuff. We really appreciate your time here. And the sound got me super interested. So we know that there's one more tool that you have here to make a little more sound. And that just all started from an elephant, right? It all
that
started
was-
from why does an elephant make
Well,
that
okay,
sound?
okay. So, that one was the error. That one is a little bit different. See, it's short.
Right.
So this one, the rule of music is that when you have a tube, waves confined in a tube, you take the lowest note, and the next break will be 1 octave away. So the lowest note on this one was 8 notes away is an octave.
Okay.
Okay, and then I go up, it'll be about 5 notes away, less than 5 notes, but more than 3. So I got 4 notes on this one. I can't do jazz on 4 notes. I
Yeah.
can't. So the medium length one was just right, because if I go with the long one, then it's like an elephant's trunk.
Yeah.
It's just too bloody long. There are too many waves. You hear there's no distance between it. So here's the way that works.
Okay.
Okay, in a confined tube, let's say I've got the note A. It's 440 hertz. In a confined tube, the single wavelength is the note A.
Yeah.
Now, if I double that, it becomes 880 hertz, and that is 1 octave away.
Okay.
But when I add the next break, it's another set of waves, but it's 1320 because we've added 440.
Right.
It's not, if it was 1760, then it would be an octave.
And you would see 4 of them, right?
And I
'Cause it
would
go
see,
1,
I would
2,
have to
4,
see
but
4 of
instead
them.
we want 1, 2,
If I want to do
3.
an octave, I've got to do 4. So that's
Right.
the 5, and the balance of the 5 is to the 8 to the next one, and that's when we add the 4th one.
Right.
And so it's the laws of waves. See, okay, laws of waves. It was great. We did the technology integrating engineering where the kids did the rap music video.
Yeah.
Okay.
Okay.
And the formula is, if you take a central concept and you repeat it over and over again, that gives you your cadence and your note variation.
Mm-hmm.
And so these kids were really sharp to that. They said frequency for pitch, amplitude for volume,
Right.
frequency for pitch, amplitude, the height of the wave and the length of the wave. Okay, so that's how you make your rap music video. They were better at it than I am. Okay, so I've got this music grinder, see, and it's got short tags and it's got long tags.
Okay.
And so if I turn it, it's almost inaudible.
Yeah, you can hear it, but barely. You can
Just barely
hear it.
Well, what's missing is the amplitude. Frequency for pitch, amplitude for volume.
So we have some different notes in there, but we just can't hear it because the amplitude's not big enough.
Well, let me use the tabletop here. I'll use the whole tabletop here.
Wow. So the whole table is
Becomes the amplifier. It's
Yeah.
kind of like I put a hex nut inside a balloon.
Yeah.
The faster I spin it, the higher the pitch.
Right.
But it's a small balloon, so if I inflate the balloon bigger, now it's much louder because there's more amplifier.
Right.
It's just like when I do my Jew's heart. Just like when I do my Jew's heart. Okay, I go. Now, I'm changing the pitch with the size of my mouth.
Right.
I'm creating the vibration with the tang, but when I open up my lungs, my alveolar lungs, all the surface area of my alveoli now becomes an amplifier for the sound, and so by opening my lungs,
Wow, it's a lot louder there. So there's so much to learn, and to think it all started with us thinking about how an elephant makes a noise, right?
there you go.
Well, Mr. Hanley, we are so grateful to be here today. We want to make sure we leave you with something because I know we're always adding to the museum. This is our Do the Math tile, and you'll know that we visited just because maybe, you know, on the floor when you enter, or maybe in the restroom or something like that, but we want to make sure that we leave you with a token of our gratitude for being able to show us some really amazing things, and just a reminder that doggone, math is everywhere, you know that, but the people who come in the door will also be able to know, you know, there's a lot of math in this place, not just science.
They'll know we are duly tiled.
That's right, you got it.
Yes, brother.
So today, a little bit of math in the real world. So excited to have been here today, but we know there's a little more math to do in the studio as well. So
Glad
back
to
to
be
you.
here.
Yeah, thank you.
All right, well, we do have phone tutors available until 5:30 this afternoon. Did you have fun today, Makai?
Yes, I
Well, we
am.
certainly did appreciate you coming in this afternoon. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.